Small size example. Welcome back to our statistics learning session. Today we'll be talking about a small size example. What if n is equal to 20 and m is equal to 12, where n is a test group and m is a control group? In this case, obviously, we cannot use central limit theorem and then we cannot use Slutsky's lemma because Slutsky's lemma depends upon central limit theorem to do its magic. Now, what we need to do is, since this cannot be asymptotic, we need to do something else. But before that, let's discuss why do we need this to be asymptotic. We need this to be asymptotic because we need to apply central limit theorem. And to apply central limit theorem, we need to bring the expression in this form. And when we bring the expression to this form, we need to apply central limit theorem by doing this. But we don't know sigma square, and by using Slutsky's we can substitute sigma square with sigma sample sigma square. Given that, and in this case what we have is we have x through xn as a normally distributed sample size. It's a Gaussian distribution. Now it turns out that if the sample is itself a Gaussian distribution, then we have some flexibility. That is, we don't need the we don't need this distribution to depend upon mu or sigma to compute its quantile. We can compute a quantile by using numerical integration. Of course, we cannot compute quantile using closed form as we have done before, but we can compute quantile by doing numerical integration. Fortunately, people have done this for us already, and you can see those things on website or back up the book at several places if you want. In the end, let me quickly summarize what we learned today. If the sample size is small, then we cannot apply central limit theorem, and consequently we cannot apply Slutsky's lemma. Because of that, we need to understand what the sample is distributed on. If it is a normal distribution, then we can use the numerical integration to compute a quantile as needed, or other distribution, or it can be gamma distribution or student distribution. For that, we need to understand the distribution itself and use a numerical integration to compute a quantile we need. That's all for today. I will see you next learning session. Thank you so much.